Hey guys, so we are starting at 8.1, and this is about the conic section circles. Okay, so there are 4 conic sections that we're going to talk about. Circles, parabolas, hyperbolas, and ellipses. So in that order. And those circles is the first one we'll talk to. In the second, we'll see why we group those 4 shapes together and we call them conic sections. But before I do, I wanted to show you this formula. This is the one we're going to need for our lesson today. This is the general form of a circle. And the h and the k is the center of the circle. So it's x minus h quantity squared plus y minus k quantity squared equals r squared, or r stands for the radius. So h and k is the x and y value of the center. R is the radius. So this way you can graph a circle on your calculator, but we use this equation. You just tell your calculator where do you want the center located, where do you want the radius, and use this equation. You'll have to solve it for y, of course, if you're using on your TI-84, but if you're using Desmos, you can type it in just like this, and it'll give you a circle. Okay. Well, we're going to use this equation to solve some problems. So, yeah. Screen share. Go. And the first thing we're going to look at is why do we call these conic sections? So this little hourglass looking thing is called a conic, conical surface. Now, there are 4 different ways I can slice it. We'll see our first way, I can slice it diagonally, and it makes a parabola. If I slice it exactly horizontally, it makes a circle. If I slice it at an angle, but not so much that I go off the end like the parabola does, it makes an ellipse. And if I slice it vertically, I get basically 2 opposite facing parabolas, which we call a hyperbola. Okay, so these are our 4 different ways I can slice the conical surface. So that's why these are our 4 conic sections. So circle is going to be our first one, 8.1. We'll move on to ellipse, 8.2, and then hyperbola will be 8.3, and then parabola will be the last one at 8.4. Be the end of our chapter. So let's look at our problem today. I'll go ahead and tell you this is going to be a pretty short and extremely easy lesson. Circles are definitely the easiest, not a whole lot to it. So I'm looking at this equation. It says identify the center and the radius of each. Well, let's look at our formula right here. Okay, so center and radius. So I'm going to write down problem number 1. It says x minus 15 squared plus y plus 11 squared equals 11. All right. Pull the video full screen. So here's our equation. You see it matching. We just got to figure out what's the center, what's the radius. Well, this value is the x value of the center. And notice it's x minus h. So I want to do the opposite sign because it's minus. If it was plus, I'd keep the signs the same. But because it's minus, I'm not going to say the x value is negative 15, because if I put negative 15 in for h, a minus and negative actually make this positive. So that's what we're doing the opposite. Okay? So my x value is positive 15. Right here it says y plus 11. Well, the only way I can get positive 11 here is if I had put a negative 11 in for k. So minus 11. There's my center. All right. Oh, radius. Well, this value squared is the radius. So what number squared makes 11? Well, I don't know exactly which number, but I know it's the square root. So I'm just going to write the square root of 11. Okay, it's going to be some decimal, and I'm not really too concerned about what that decimal is. There's my center. Here's my radius. Simple as that. These are the next 2 problems. If you want to pause the video, you can, and I'm going to show you the answers. All right, so the answers to 2 and 3 are 9, 15, radius of 2, the square root of 4 is 2. And here, 14, 1, and the radius of 1, the square root of 1 is 1. All right, moving on. What if they give me a center and a radius, and then ask me to find the equation? The center is 0, 0. So center is 0, 0. So I'm just going to plug into this formula right here. Okay. So I have x minus 0 plus y minus 0 equals, and I have my r, which is the square root of 183. But I need to square it. And then I'm going to simplify. Well, x minus 0 is just x. So I can rewrite this as just x squared. Same thing here. We just y squared. And here, the square root and the squared cancel out. So I'm left with 183. So from now on, whenever your center is 0, 0, you're just going to have x squared plus y squared. So if you ever see x squared plus y squared equals a number, you know the center is 0, 0. If only one of them is a 0, then, well, only one of these is going to be x squared or y squared. The other will have a number with it. Okay. So there we go. Number 4. Go back to go. All right. You can go ahead and pause if you want and try number 5. The answer in just a second. All right. So number 5 is x squared plus y squared equals 144, because 12 squared is 144. Let's look at, I'm going to try number 7. 7. Center, negative 5, 10. Radius, 4. So again, plug into my formula. Now, h is negative 5, so minus negative 5 means I'm going to have x plus 5, and then y minus k, so y minus 10. And then I'm going to go ahead and square my radius. My radius is 4. Well, 4 squared is 16. That's as simplified as that one gets. So I skipped number 6, so chance to pause it and try number 6. All right, number 6 is x minus 10 squared, and then the y squared is by itself because the y value is center 0. Of course, 6 squared is 36. All right, how about number 8? Go ahead and pause the video, try number 8. All right, number 8 is x plus 6, y plus 6, and then the square root cancels out, and I'm left with 166. Okay. This one's slightly different. Instead of giving me the center and the radius, it gives me the center and a point on the circle. I'm going to write this down. Now there is a shortcut way that works for number 9. However, that shortcut wouldn't work for the following two problems I'm going to let you try, so I'm going to do the loan method for number 9 because that's what you're going to have to do for 10, 11. But then I'll go back and show you. All right, so again, my equation uses the center, which I have, and the radius, which I don't have. Well, remember that if I have a circle, and I have a center, and I have some random point on my circle, the radius is the distance from the center to that point, my R. So I want to find the distance between these 2 points, and that gives me my radius. Okay? That distance, or in this case I'm going to say R, is the square root of, and I'm going to say it's x2 minus x1 squared plus y2 minus y1 squared. By the way, should look a lot like the equation of a circle. Notice I can square both sides, and then get r squared equals this without the square root, and that would look just like the equation of a circle. It's not accidental. All right, so here's our equation. I'm going to plug in. We'll label this one x1. Oh, and I just realized I didn't stop share. Sorry. And my video's been really small, so I'm going to give you a second to catch up. Actually, pause if you need to. This is my equation. This is distance formula. Instead of the D here for distance, I put R because R is the distance from the center to the point on the circle. So I'm going to call this one x1, y1, x2, y2. I could have switched them, doesn't matter. And now I'm going to plug in. R equals the square root of negative 15 minus negative 6, so plus 6 squared. And then 0 minus 0 squared. Okay. Negative 15 plus 6 is negative 9 plus 0 squared. Negative 9 squared is 81. 0 squared is 0. 81 plus 0 is 81. Square root of 81 is 9. Except that, remember, I'm just going to square this value. So really, I cared more about this right here than anything. So after I combine those two terms, that's the number I want because I'm just going to square the radius. And so that right there is going to be the value. Okay, if I think of it as 9, but 9 squared is 81. So when I plug into my formula, I have x minus, well, my center is negative 6, so it's going to be x plus 6. The y value is 0, so we have plus y squared equals, my radius squared is 81. Okay, so that's how you're going to do it on most of these problems where you have to do the center and point on the circle. However, I told you there was a little bit of a shortcut you could have used on this one. And that is because both of my y values were the same, the distance between these 2 points had to be just the distance of my x value. So the distance from negative 6 to negative 15 is a distance of 9. So I could have used that. That only works if either my y's are the same or my x's are the same. All right, so go ahead and pause the video here and we'll try numbers 10 and 11. All right, so the answers to 10 and 11 are right there. All right, last we're going to look at, I'm going to try number 14. It's new fraction, maybe that was scary. It's important that we remember what area of a circle is for this one. So I'm going to write down the problem. Center Square root of 11, 15 over 2, radius, oh sorry, radius, area. So this is what I'm going to do. Area of any circle is pi r squared. Okay? Area is pi r squared. Now let's think about this. If area is pi r squared, and I know that my area is just pi, so I'm going to replace area with the area they give me, pi. Well, then I would divide both sides by pi, leaving me with 1 equals r squared. Take the square root, r equals 1. So what you're going to find out is whatever that number is, so let's say this one was just 1 pi, let's say it was 2 pi. 2 would be the radius squared because area is just radius squared times pi. So whatever number is in front of pi, that's your radius squared, which really is all we care about. So I took the square root really out of habit, I guess, because whenever I see a square, I always think, oh, take the square root. But really, I could have stopped there because all I cared about was the r squared. So now I can plug into my equation and say, okay, I have x minus square root of 11 squared y minus 15 over 2 squared equals, and then r squared is 1. And I know we'll have square root of 11 and a fraction in there, and that's perfectly okay. Leave it like that. All right, and that was the last type of problem I have. So we're going to look at the answers to the two I skipped. Here's number 12, and Paul's in 5. All right, answer 12 is right there. And then number 14, pause the video now. All right, the answer 14, right there. Okay, that was the end of 8.2.